This sample problem is going to cover wall framing. So there'll be two different sections. The first section will have problems 1 through 8 as well as 9 through 17. We'll be looking at two different wall systems. We have our 2x6 walls as well as our 2x4 walls. These are all related to Plan 100 and it is a basement foundation. We are also going to be counting all of the studs in these walls, therefore we need to look at our openings, and then we will be converting everything into board feet once it is all done. We want to make sure that we read our plans and specs and that we look at all of the information that is provided. We're going to look at our 2x6 interior walls. In our Plan 100, we're mainly going to be looking at our floor plan. Again, all of these drawings are posted on Blackboard for your reference to print out and use while working through the lecture activity during class. So the only 2x6 wall that is noted on the plans is in between our bathroom and our kitchen. This is typically referred to as a plumbing wall due to the plumbing for the sink, the toilet, and the tub, as well as the sink in the kitchen and potentially a water line for the refrigerator. There are going to be a lot of pipes in this wall, and therefore making it a little larger will account for the thicker pipes that might be used, as well as potential or reduce the potential of nails or screws penetrating those pipes, both supply and drain lines. So we can see that this is the only 2x6 wall that we have to deal with, and it is roughly 10 foot 9 inches in length. This one goes from inside to inside, depending on how you frame it. That might be the case. You might go to the outside. On this one here, if you wanted to break this wall up, multiple ways of doing it, but chances are this 10 foot 9 is an accurate representation. In general, you're going to add waste when you actually do an estimate, so we are just going to try and be as close as possible, but we don't have to be extremely detailed when we're pulling off these estimates at this point. So we're starting off with the lineal foot of 2x6 walls. So lineal feet of 2x6 walls. And there's no calculation for this. It is just our plumbing wall, as we said from the drawing. And we can pull that dimension straight off, 10 foot 9 inches, or if we wanted to list it as a decimal, we could just say 10.75 feet. It's always good to work in feet so that you can easily convert and not have to worry about going between feet and inches. Number 2 is looking at the number of studs. So this is a counted item, a repetitive item. We covered repetitive items when we were talking about our floor framing. If we have our length of 10.75 feet, we divide it by our 16-inch spacing. This is given to us in the specs for Plan 100, so make sure you're reading that. It is not listed on the floor plan, it is in the specs. We can see that we have 8.0625. So even though this is a very minuscule decimal place, I want you to get in the habit of always rounding up. So we are going to round up to 9. But remember, this is not the number of studs we are using, this is the number of spaces. In the case of our stud walls, we need to add one rather than subtract one. So in the case of our stud walls, we need to make sure we add one, we don't subtract one, because we need to close in our wall. As if we have a ladder and we've gone all the way, we need to add this one to close off this last space so we have a fully framed wall. So total, we're going to have 10 each for our stud walls. This is for our 2x6. Number 3 then is looking at the total lineal foot of 2x6 studs. The two different heights of studs, if we have an 8-foot ceiling height, the stud length is going to be 92 5/8 inch. This is just standard in the industry, and we'll discuss how we get to that length a little later in the sample problem. For a 9-foot ceiling height, it is simply going to be 104 5/8. So you can easily see you simply added 12 inches or 1 foot to have that difference. So if we know each one is going to be 92 5/8 because we have an 8-foot ceiling height, we can simply take our 10 that we just calculated, knowing we have 10 studs at 92 5/8 inch. We divide by 12 to convert into feet, and we have 77.1875, and I have simply rounded to 77.2 feet. Number 4 is now looking at the lineal foot of 2x6 plates. So total in a typical wall system, we have 3 plates. We have a double top plate, and we have a single bottom plate, sole plate, base plate, multiple names from it. It is not a sill plate unless it is a slab foundation. So we need to make sure that we at least distinguish between that. Since we know we have 3 plates that are running the top and the bottom, we can take our 3 times the length of our wall, 10.75 feet, and we get 32.25 feet. Then 5 is looking at the total lineal foot of lumber needed for the 2x6 wall. So that counts both plates as well as studs. So in simple addition for number 5, we are taking the 77.1875 feet for our studs. We're taking the 32.25 feet for our plates, and we end up with 109.4375, and I'm simply going to say that that's 110 lineal feet. It is not a board foot, however, so we do not need to round it up to the nearest whole number, but if you want to, that is acceptable. In number 6, we are converting to board feet. This is a 2x6 wall, so we know we're using 2x6. So our board foot factor, we take the 2x6 over 12. It is simply 1.0 board feet per lineal feet. If we multiply that by the 110 lineal feet, we end up with 110 board feet. That's the nice thing about 2x6, the board foot and the lineal foot equals. So if we use our unrounded number here in our calculation, the 109.4375, we would still have to round up the board feet to the nearest whole number. So either way is fine, but your answer for board feet does need to be a whole number. So that is all of the lineal footage for the 2x6 wall converted into board feet. But we also have our 2x4 walls. So the rest of the walls in our Plan 100 are going to be 2x4 walls. Number 7 is looking at the exterior walls. Typically when we are working with framing, we do not do centerline. We can use our simple exterior dimensions, but we want to make sure we're pulling the correct ones. We have the 36-foot length that we're used to dealing with, but here we need to be careful that we're only dealing with the 26-foot width. We're not using the brick ledge. That will have brick in those additional 4 inches, so the framing is only 26 feet. So simple math gets us 124 feet is the exterior wall perimeter. Number 8 is a little bit more in depth. It is looking at the lineal footage of 2x4 interior walls. Now there's multiple ways of doing this. You just want to make sure that you're not double counting your walls. Again, all of these are on Blackboard. So what I have decided to do is go through, highlight certain areas to make sure that I am not double counting. It's very common to use colored pencils, highlighters. A lot of systems such as on-screen takeoff will allow you to do this so you can see what you've already counted and what you still need to count. You could go by room, so I could do the lineal foot of walls in bedroom 1, bedroom 2, bedroom 3, but as you can see, 2 and 3 share a wall, so that could be a potential for double counting. You just need to make sure that you are not doing so if that is the method you choose. So what I've decided to do is look at the 2x4 interior walls running side to side of the house. So anything that on this page is running horizontal is going to be counted first when I'm putting together the lineal footage. So the pink line, as I have noted on here, runs the full length of the house, so all 36 feet. If you have an opening, you still have to count that in your lineal footage. You're still going to have a top plate. You'll still run the bottom plate and cut that out later. Yes, you'll have studs that are missing in those areas, but you still have to account for those because typically they will be moved over to be a king stud or a jack stud. So we do not subtract out openings when we're counting our interior studs. There is a gap in this kitchen area as a walkway, but we also have this short little half wall behind the closet, so it runs the full height, sorry, but if we move it over here, it is approximately the length of the house, so we can just get a rough number for that. So we know from side to side, we have a 36-foot dimension that we are going to include. Next, we have this green line. So the green line runs the length of the house minus the living room. So it runs through the hallway, and if we can do a little jog over, it runs the front of the closet in bedroom 2. So we have a living room dimension of 13 feet 1.5 inch. We don't need to be incredibly precise again on these pulling the dimensions. You don't want to necessarily round to the nearest whole foot, but because this is only 1.5 inches, we can simply subtract that out. Say it's roughly 13 inches, especially in this case since we're rounding down, it will account for any additional air that we might have. So that is the 36-foot length of the house minus the 13 feet, which gets us 23 feet. So additionally, we have the 36 feet minus the 13 feet from the living room. We have approximately a 2-foot and a 6-foot area. We've pulled these dimensions from the prints. This one says 6 foot 2.5. Again, we're going to just use a rough number at this point, so we can say approximately 6 feet. This one does actually give a 2 foot 1 inch dimension, and most times on plans you won't see that dimensioned. It is standard in industry for a closet depth to be 2 foot 1 inch. We frame it this way because once we run drywall on the back side and drywall on the front, which is a 1/2 inch for each, that will get rid of the 1 inch, and you'll have a clear depth of 2 feet within your closet. So we have our 6 feet that we have to add plus the additional 2 feet. We total this all up and we get 67 feet worth of 2x4 interior walls that run side to side of the house. Next up, if we are looking at the walls that are running front to back of house, or in this case, if we're looking at it as the vertical lines, we can try and lump a couple things together. We don't really have anything that runs the full width of the house, but we can pull some different dimensions. So for example, if we just start over here on the left-hand side and work our way over, we see that we have a stair wall in our kitchen. It is not dimensioned on the plans. However, we do know the width of the house, and we know that the living room is approximately 13 feet in depth. So again, we can subtract that out. for our calculation. We have our 26 width minus the 13 feet. Next up, we encounter the walls on either side of the closet for bedroom 3 and the living room, as well as the additional wall between bedroom 3 and bedroom 2. We can see that they are all the same length, so we can save on our math. If we know that they are approximately 11 feet each, we can simply take 3 times 11 feet in our calculation. And next up, we have our red dimensions. Again, it's the side of a closet, so it is not dimensioned on the plans, but we know the standard depth is 2'1", so we can say it's approximately 2 feet. We have our side of our 2 closets, no dimension here again, but over here we see that we have a 2'1" and 2'1", and if we account for the wall in between, it might bump it up to closer to 4.5 feet, but for now we can go ahead and just estimate it close to 4 feet. And the last one we have yet to count is the green between bedroom 1 and the bathroom. This is a 2x4 foot wall, so it is the 10'9" or 10.75 feet. So if we add all that up, we come up with 62.75 feet. That only gives us the 2 separate totals, not the whole total for the house. So we have to add those together, 67 feet plus 62.75 feet. And we end up with 129.75 feet, which I have simply rounded to 130 feet. So again, we don't have to round it up to the nearest whole number, but it does not hurt if you do so. So 130 feet is the interior. In number 9, we want total wall for interior and exterior. So interior plus exterior is the 130 we just calculated for interior, plus the 124 feet we calculated for exterior in number 7. Total of 254 feet. It's the total lineal footage of all 2x4 walls. Number 10, looking at plates again. Again, we have our 3 plates, our double top plate and our single bottom plate. So we can simply do our 3 times the 254 feet, which is 762 feet. We also need to account for, like I said, the openings, the windows, doors, as well as our wall panels. So first off, number 11 is asking for the number of wall panels. The reason why we are doing this is we are going to account for our corners. There are a couple of ways of doing this. We could count the number of corners if we wanted to, and do our calculations that way. This way, we can also account for wall panels by saying, well, each wall panel is going to have a corner, it has an end. And if this wall corner has this end, this wall has this end, so on and so forth, we can look at it that way. So what I have done in the drawing is gone through, and in the green, it's listed out all the number of panels. So one side of the stair is 1, the other side is 2, the 3 runs the full length, but here we are going to jog and make that separate because as we would frame this as a full long wall, but the closet wall would be separate because it is offset. So we're simply looking at the panels separately as we go through, and if we do that, round it out with the exterior walls, we end up with 19 wall panels. So I'm simply going to write C drawing. So you can go to refresh and see where those are. 12 is looking at the number of door and window openings greater than 6 feet. So as we discussed in lecture, 6 feet is our breaking point to whether or not we would add 2 studs versus 4 studs for our openings. All of the doors are all less than 6 feet. The green circled windows, our A and our C windows, are less than 6 feet, but our D and our B, circled in pink, are greater than 6 feet. Make sure you refer to the specs. They will give you the exact dimensions for B and D, but both are greater than our 6 feet. So we know we have 2. Again, I'm going to write C drawing for you to refer back to. This is the B and D window. For number 13, we're now looking at our openings less than 6 feet. All on the same drawing. We have our doors that are highlighted in orange. If we count all of those up, we have 12. And again, the C circled in green and A window circled in green, there are 6 of those total, all less than 6 feet. So we have 12 for our doors that are less than 6 feet, and we have 6 for our windows. Total, we have 18. And again, see drawing and reference your plans and specs if you would like to look at that further. Number 14 is where we're finally going to count up all of the studs we have. I'm going to pull the sample problem back over so we can look at it a little bit more in depth. So it says calculate the total number of studs for the 2x4 walls. Make sure to count for closing each panel. So each wall panel we have to make sure we add for that. And openings. We've got our drywall clips used. Therefore, additional stud at each corner is not needed. Remember, when we frame traditional corners, we have to add 2, one to close in the wall, the second to add for the nailer. But when we use our drywall clips, we only have to add 1 to close in the wall. For this sample problem, we're not going to look at intersections. We're not going to add any additional for those. We're simply going to stick with our wall panels and our openings, accounting for the drywall clips. So first of all, we need to know our lineal foot of walls. We calculated that in number 9 when we were looking at our 2x4 walls. That was 254 feet. We divide that by our spacing, the 16 inches on center. So we convert that to feet. And we are left with 190.5. We have to round up. That is 191 spaces. At this point, do not add 1. This is not one long 2x4 wall that is 254 feet long. If it was, we could simply add 1 and be done. But this is multiple walls coming together to total up the 254 feet. So at this point, just leave it at spaces and we'll account for the studs when we look at our number of openings and wall panels. So we need to add 19, which is 1 stud per wall panel. So this is how we're adding 1 when we are coming up with our individual walls. We're closing in each wall panel by adding our 19. Next, we want to add in for our openings. We have 2 openings that are greater than 6 feet, and for each opening greater than 6 feet, we need to add 4 studs. So that's 4 studs per opening greater than 6 feet. We have 2 of those, the B and the D window, so it is 2 times 4. We said we had 18 openings less than 6 feet, so we only add 2 for each one of those. So 2 studs per opening less than 6 feet. So if we pull all of our numbers together, we have 191 spaces that we're going to add 19 to close out each of our separate walls. We add in the 8 for our wall panels over 6 feet, and we add in the 36 for wall panels under 6 feet, and we come up with 254 each. It is simply a coincidence that the number of studs equals the exact lineal footage. That's a very rare occasion that that will happen. So don't think that that is always going to be a given. Number 15 then is looking at the total lineal foot of studs. So we need to know how many we just counted. So 254 each. I want to designate that is what we're counting, our answer from number 14, not our answer from number 9, times the 92 and 5/8, because even though it is a 2x4 wall, not a 2x6 wall, it is still the same height of wall, so that does not change. 1960.56 or 1961 feet. And 16 is looking at the total lineal foot of 2x4 walls. So we need our plates, our 762 feet from answer number 10, the 1961 feet from our number 15 that we just calculated. We get 2723 feet is the total lineal footage for all 2x4 walls. Number 17, lastly, changes the lineal foot to board foot. These are 2x4 walls, so we put 2x4 over 12. We get a 0.667 board foot per lineal foot. Multiply that by our 2723 feet. We get 1815.33. So of course we round up to 1816 board feet. So the number goes down because we have a board foot factor that is smaller than our than 1. A couple other visuals that are posted on Blackboard. Again, I just want to point out what we're talking about when we are adding 2 studs per corner. We add 1 to finish off the wall. So if we have something, if partial spacing, whatever it is, we have to add the 1 so that we finish off the wall. And we add the second one if we are going to use a standard corner. In the case of using drywall clips, we have the clips here at the corner for the drywall, so this one is not needed. So if we know our number of wall panels, then we can use that as we did for our sample problem. If you're not using the number of wall panels, but you are using the number of corners, you would simply add 1 for each corner for your drywall clips, add 2 for a standard corner. So make sure you reference this visual if you are ever confused about how many studs you add per corner